Okay, so welcome everyone. My name is Mark Howarth. I'm the Executive Director of the Candlewood Lake Authority. Thank you for joining us here tonight. Just a couple of quick things before we get started. We welcome your participation and questions in this. The chat feature is enabled, so if you do have questions, please send them in through the chat feature. Once Neil is done with the presentation, we will then answer as many of the questions that come in as we can. We will wrap this up in an hour. So we have 60 minutes for this webinar. And then I will just do a quick intro here of Neil. So I just would like to introduce Neil Stalter. He is our Director of Ecology with the Candlewood Lake Authority, and he is a recently certified lake manager through the North American Lake Management Society. So Neil, after a brief intro, I'm going to hand it over to you.
Excellent. Well, thanks, Mark. And thanks everyone for joining us to learn more about the, rapid change in the plant community this past summer. Thanks for the intro, Mark. Many of you might have seen me out on our research boat this past summer doing our normal water chemistry testing, as well as the other environmental projects that we do, including, looking into this change in the plant community this year. This picture here is actually some milfoil strands we were able to find in Candlewood this summer. As Mark kind of mentioned, for this presentation, I'll go through all of our information, and then we'll save questions for the end, because I imagine I'll probably answer a lot of them sort of as we go here. Just so it's easy for us to manage, we're going to do muted and cameras off, but the questions will go directly to Mark, and then he'll read them out loud once we get to the Q&A session, and I can go ahead and answer those. Okay, so quickly, we'll just go over the agenda for the presentation. We're going to start just by giving sort of a brief history of milfoil and plant management in Candlewood. We'll talk about the historic plant issues that we've had, the steps the CLA and other lake stakeholders have taken to try to manage those issues. We'll go over a quick timeline of what we actually saw this year in 2022, followed by an in-depth discussion of some of the factors that probably contributed to this problem, the plant loss, and how we know that they likely had an impact. And then we'll talk about why, this all matters. We'll get into the ecology of, the plant loss a little bit, and the impacts that might have on the ecosystem, and what the future might hold in the next couple of coming years. Finally, we'll touch on, the CLA's monitoring and management plans sort of moving forward, and then we'll have time for questions at the end. Everything will be recorded and posted to our YouTube account for those folks who weren't able to attend. So if you had a friend or a family member who was interested but they're busy, this will be on our Facebook and YouTube for them to take a look at as well. Okay, so I wanted to initially touch on the fact that when we're talking about plants in Candlewood Lake, we're really talking about one dominant species of plant that represents about 80% of the plant community historically in the lake. And that plant is, of course, Eurasian water milfoil. This is an invasive species. It was introduced in the lake in the early 1980s and rapidly sort of took over the ecosystem and made it a monoculture ecosystem, so dominated by one plant species. Historically, the stands of milfoil have actually been so dense and tall, many of you probably remember this, that they presented a recreational nuisance and hazard. They outcompeted any other native species in the lake, in the ecosystem. Here's a picture here. This is Allen's Cove up in Sherman in 2016. And I wanted to also point out, since 2008, there have actually been annual surveys dedicated specifically to looking at the entire plant community on the lake. And we'll be able to look at some of that data tonight. Here's a map actually from the 2018 survey of Candlewood conducted by Northeast Aquatic Research. Here in this map, you can see the Danbury arm of the lake. All of the red is milfoil beds, and the darker the red, the denser it is. So this is 2018, obviously not this year, but I just wanted to, illustrate one of the maps that comes from those surveys and the high density plant coverage we've had in the past. We're going to talk a lot about sort of plant management tonight, and I wanted to be specific about what that means in Candlewood. And so in Candlewood Lake, there have been two main strategies that have been used to try to manage the plants to a healthy level. And when we're talking about managing the plants, we're saying these are strategies that have been used to try to balance the total amount of plant material. Another word for that is biomass, to a lower, healthier level when it was too dense in the past. We'll talk more about striking that balance, what that means a little bit later in the presentation. But the two strategies that have historically been used in Candlewood are the winter drawdown. So that is, what actually has just begun this week on the lake. And that is the annual shallow or deep lowering of the water in the wintertime by First Light, the owners of the lake. And what this does is it exposes the shallow shoreline to the cold air in the winter. And the hope is that it will basically freeze plant material and the root systems of those plants in the shallow areas and, keep them at a lower level, make it harder for them to grow back that following season. And so that is the winter drawdown. And then the other management strategy that has been used in Candlewood Lake is, of course, the stale grass carp stocking. And that was a program through the CLA and the Connecticut Department of Energy and Environmental Protection. And what these fish, they were introduced two separate times into the lake, excuse me. The first was a stocking of 3,813 fish in 2015. And the second stocking was a stocking of 4,450 fish in 2017. Those were the only two stockings in Candlewood Lake. And the ultimate goal of, and that stocking rate is the amount of fish that number came from was 15 fish per acre of milfoil found during those annual surveys. So you take the total acreage of milfoil that had been found in those surveys, you multiply that by 15, and that's where that number of total fish came from at that time when they were stocked. The ultimate goal of stocking those fish, of course, was to basically, they eat from the top of the plant downward. And so the thought was they would lower the plant biomass to a healthier level and then also lower the plants in the water column so they are no longer at the surface of the water and they're no longer presenting a recreational nuisance, but the plants theoretically would still, exist, but they would no longer be at the very top of the water. It was never to eliminate all of the plants entirely, but we'll talk more about, that shortly. I wanted to show you this graph. This is total plant acreage every year since 2006. And I think this illustrates just a couple of things. The orange lines here, these are years where the winter before that summer was a deep drawdown. So for instance, in 2011, that summer was following a deep drawdown. You can see the years where there is not a deep drawdown. The lake tends to exist at this level between 500 and 400 total acres of milfoil. So that's a lot of plant material. But the lake likes to sit in this range here between 400 and 500. And you can see historically when there's no deep drawdown, that tends to be where the lake likes to sit. I've also just highlighted, these are the 2 years where the grass carp were stocked. I just wanted to highlight that for you, of course, sort of putting this whole picture into context. Obviously, this past year, 2022, represents a really dramatic change when you're looking at total acreage, going from roughly 400 acres last year of plants in 2021 to effectively 0 this year. But there are other metrics that are really important to consider, including plant height and density when we're talking about plant material. And so we're adding, as we go through this presentation, we're going to talk about all three of those metrics when we're talking about biomass, that measurement of all of the plant material in the lake. I wanted to go through quickly the timeline of events as we saw them and other Candlewood Lake stakeholders saw them this year. So in January of 2022, so last year, it was a medium depth drawdown. That was set between the normal deep and shallow levels, and that was done to potentially help manage actually the zebra mussels potentially that had been found in Candlewood up to that point. And then there were a few other factors that were considered when that decision was made. And then, so deep, medium drawdown that winter. In March, the lake is refilled. And then in April and late April and May, we actually began to see plant beds start to grow in Candlewood Lake. And these were seen using sonar. They obviously were not, up to the level like the picture in Allen's Cove from 2016. We're talking about the beginnings of growth at the bottom of the lake using sonar. And, you do see some breaking off of the bottom and floating to the top a little bit. But this is when they began to grow. In June, it quickly became clear that that growth that had been seen at the beginning of the season with sonar had slowed down in a lot of areas and completely stopped in most. And stands of plants that had been seen starting to grow were either starting to dwindle or disappear completely. By July of this year, virtually all the plant material in the lake was gone. It was difficult to find any plants, a few strands here and there, but it took a lot of searching to find the existing plant material in the lake. August was the annual plant survey. That is conducted in August every year. So that's why it was in August again this year. This is obviously in addition to all of the sort of smaller surveys that the CLA did, that other organizations like the Agricultural Experiment Station were doing during this year at the beginning of the season as well. So this was the main large huge lake survey, but there were other smaller surveys happening before them too. In September and October, we did actually begin to see this again with sonar. There was nothing rising up to the top, but there were a small number of beds that showed some modest regrowth. This is, a very low amount compared to what we saw in the past falls, in a normal season, but we did start to see on sonar some plant beds begin to regrow in September and October a little bit. And then I just wanted to point out, this past week, actually, First Light began their drawdown. We were initially hoping maybe to have a shallow drawdown this year to help maybe give the plants an edge this upcoming season. Unfortunately, First Light needs to conduct some maintenance that requires them to do a deep drawdown. So that is what now has begun. Okay, let's talk about the factors that likely contributed to the loss of plants based on the conditions that we're seeing in the ecosystem. The most obvious and the first is that the grass carp are in the lake, they're eating the plants, right? And they have grown to a larger size than when they were initially stocked in 2015 and 17. And they're eating probably more efficiently than what was initially suspected when they were first stocked. And I also, maybe even more important than that though, I want to point out that they actually have been consistently reducing that total biomass amount of plant material over the past 4 years or so. And we'll take a look at some of that data and you'll see what I mean, that over the past 4 years, we actually have been pretty consistently losing plant material in a less obvious way than just total acreage. Let me see. But we're not only talking about the grass carp here. There are a lot of factors that play that impact the plant community and that actually precipitated this major change. The drawdown in 2022, that medium depth drawdown, is beginning to look like it was very effective. And what I mean by effective is it accomplished its goal of effectively exposing those shallow plants to the cold air and potentially freezing those root structures of the plants that had existed the season before. The plant communities in the lake also sort of have a natural boom and bust cycle. Normally, this is pretty subtle. It's not something that you would really notice in a change year to year with the plant community. But certain years are better for plant communities as they sort of compete with each other for resources and space to grow. And so that may have played a part. You may have seen that quote unquote bust cycle sort of coincide with these other factors. The only other thing that I want to point out, this is something we've started looking into. It's not necessarily something I know had a major impact, but we did actually have good ice cover on the lake for a little while last year, and then that was then covered by snow. And what happens with that is the snow actually reflects most of the sunlight that would otherwise be entering the lake and potentially preserving some of the plant material over winter in the water. We'll talk more about that overwintering of the plants shortly, but that also may have been a factor. So that's something else we're looking into. So I'm talking about all these factors. What does this all mean, right? What am I saying? So the punchline really is that the total biomass of milfoil, the amount of plant material in the spring, was at a lower level than what we have normally experienced. And the large carp that are present in the lake began feeding at a rate that was faster than that lower level of plants could grow. So the carp effectively, quote unquote, won the race against the plants and lowered the population to virtually zero. And so to make that clear, I'll show you a graph about, basically what I'm saying. So these are two graphs showing total amount of plant biomass. Remember, that's the volume of plant material as a percentage over time on the green line in the lake. And the yellow line is a percentage of carp feeding activity. I also just want to quickly say these are not exact percentages. These graphs are simply to express this phenomenon in graph form. So these are just to illustrate, basically the theory, the hypothesis that we have at this point. So on the left side, this is Candlewood. This is a lake with no grass carp and no other management techniques, maybe a shallow drawdown, right? You see we're losing some biomass in the wintertime. And there's some natural, actually, loss of plant biomass in the wintertime. The problem is milfoil is actually a very hardy plant, and it likes to stick around over the winter. And so that's why the decline here in this green line from the summer 100% to the wintertime is actually pretty low. Some native plants sort of naturally die back in the wintertime. Milfoil tends to like to stick around, but it stops growing. But you do lose some in the winter just from, something like a shallow drawdown, natural loss, but not a whole lot in a milfoil lake. And then the plants quickly grow back in the spring, hit the early summer, and then hit that 100% biomass in the summer, the maximum amount that they're going to reach for that year until the water temperature is cool, and then they start to go back down again for the winter. So on the right side is a graph of what probably happened, of what graphical representation of what happened during the 2022 season. So we did see plant material at the beginning of the season, but the initial amount here was lower than what has been seen in the past. So you can see here at the beginning of the year, this initial amount has been pushed down by some factors. And nobody told this to the grass carp that are in the lake. And so they, wake up in the spring and they're like, all right, it's time to start feeding. And they feed at their normal rate. And they begin to ramp up as the season goes on too. They're feeding into the summer. And that's right when the plants are starting to recover from this lower starting level, lower amount of biomass. And the carp are eating, rapidly at their normal rate. They're ramping it up, and they, basically bypass this plant growth at this nexus point here. And the plant growth plateaus as the grass carp eat more, and then quickly collapses. The carp are eating it faster than it can grow. It's losing material. It's not reproducing. And then you get to that zero level that we saw in the middle of the summer, in the early summer, middle of the summer. And so when we're asking what caused this rapid loss of plants, what are the reasons that this happened? What we're really asking is, what are the factors that actually pushed this beginning level of biomass down to a lower level that the carp were able to win this race? And those factors are here in this box, right? We're talking about the carp are growing, they're eating efficiently, they're lowering the biomass consistently over the course of a few years. You potentially have an effective drawdown, you potentially have plant population changes, and you have some climate factors that may be having an impact too. And so I wanted to point to evidence that we've been losing this plant biomass actually over the course of the past few years. And so these are sort of the three factors that I mentioned that sort of go into biomass. And these are all from this past year's 2022 draft plant survey report from Northeast Aquatic Research. So, thank them for their hard work and looking into this as well. And so when we're talking about plant biomass and the like, we're really talking about three distinct variables. We're talking about total acreage, of course. As you have more acres of plants, you're going to have more plant material. But you're also talking about the density of those plants. So as those beds are more dense, you have more plants in a given acre of milfoil than you otherwise would. And then we're talking about plant height as well. So taller plants have more biomass than a shorter plant, but it's still the same number of acres of plant material, right? So, so as these three factors decrease, that green arrow on the past slide, this arrow that's pushing down on this biomass, that is getting stronger. So this line is getting pushed down even farther. And so this is just a clip from that total acreage graph from earlier in the presentation. You can see this is 2018 through 2021. And you can see we've actually lost total acreage over the past 4 years. In 2018, we were just over 500 acres. And in 2021, we were just over 400 acres. So that's 100 acres of plant loss that, didn't necessarily raise any alarm bells, but we are losing biomass here. This table here is our plant density categories. You can see there's dense, moderate, and sparse categories here. In 2018, I just wanted to, sort of highlight this. The percentage of total acres that were dense in 2018 was 81.7. And then this past year in 2021, obviously 2022, it was 0 because there were no plants. But when we're looking at 2021, the percent of total acres that were dense went down from 81.7 to 64.3. And so you're losing biomass in a loss like that as well. And then finally, the last thing I wanted to touch on is that plant height. And so these are graphs of the frequency of different heights of milfoil in the lake. The farther right on this graph, the taller the plant. And so you can see 2020, most of the time you're, close to the surface. This is all the way to the top, this far right. This far left is, basically at the very bottom. So you're pretty close to the surface over here in 2020. And then you can see this left shift on this graph here in 2021. Our plants are losing some of their height. Perhaps the grass carp are eating from the top down like they do more effectively and keeping those plants at a lower height. And so what does this all mean, right? Why do we care? What is the impact on the ecosystem? And so that leads us to sort of an important ecological theory called alternative stable states. And when I'm saying theory, it's sort of like gravity is a theory, right? It's sort of a very well-respected phenomenon. But this theory in a nutshell basically states that a given ecosystem will tend to stay in one of two opposing stable conditions unless disturbed by an outside force or a change. So this figure on the right is showing a visual representation of this. Think of the green ball here as Candlewood's ecosystem. And its two stable conditions, in regard to this, is overabundant plants. Macrophytes is another word for aquatic plants, or very, very few, virtually no plants at all. And historically, the ecosystem has sat in this stable state here in overabundance. But now, this past year, obviously, that stable state has transitioned over here to this state of very, very little plant material. And so how did this happen, right? In the past, the plant management techniques that I mentioned to you all before are the grass carp and the drawdown, of course. Those are attempts to basically push the ecosystem ball, this green ball that represents Candlewood's plant ecosystem, up this hill a little bit, to balance it at a point in between these two stable states where there's a healthy amount of plant material, both for the lake's ecosystem and for recreation, for swimming, for fishing, all the things that we love to do on the lake. As you can imagine, we're talking about a literal balance here. And so this is a tough balance to strike. You can see the ecosystem generally wants to fall back down, and historically it has, into this stable state of overabundance. Usually those management techniques are not enough to push the ecosystem up. And that's why since the 1980s, when this plant invaded, you're talking about a lake that has overabundant plant material. That's, a nuisance and difficult to, enjoy the lake. So normally it rolls back down and we're back to overabundance. Obviously, this past year, that push was too strong. The factors that were pushing the ecosystem up the hill, all of those things that I mentioned, the grass carp, the drawdown, the other natural changes in the ecosystem, all of those things are pushing this ecosystem up this hill. And this past year, it reached this tipping point and went to the other stable state of very few plants. This is called a regime shift in this theory. But now basically, the ecosystem will tend to stay in this stable state until some forces act on it and push that ecosystem ball back the other way to try to get some of the plants back. You can see that obviously the state of very few plants is higher up on this graph, right? That was on purpose because in an ecosystem the size of Candlewood, the fit of Candlewood for plants, it's actually easier for it to move back towards that overabundance. That's why so often in the past, the ball has fallen back towards that state of overabundance. And so the trick now is to see what forces can still be used to push the ecosystem back up the hill towards the other stable state while still trying to strike that balance between the two. Because, the ecosystem, once you go past this tipping point again, it's going to want to go back to this other stable state of overabundance. So we're still, we'd still like to try to strike that balance, but it's difficult. And so those forces that might begin to push this ecosystem back towards the other direction are the natural death of the grass carp, potentially removal of the grass carp, less intense drawdowns, milder winters, all of the things that might give the plants an edge at the beginning of the season. Those are forces that are going to start pushing this ecosystem back towards this other stable state. And other things like protection of areas of plant growth, et cetera. And so what does this look like moving forward? So the goal, of course, has always been, and this hasn't changed, is to strike a balance, like we talked about, of healthy plant levels in the lake. Plants are very important to a healthy lake ecosystem, so we definitely do not want a situation where the lake is completely devoid of plants forever. And so specifically what is happening this upcoming year, the CLA is investing in some new technology to equip our research vessel with better side scan sonar and GPS locations, tracking, so we can start our plant surveys even earlier in the season, keep a very close eye on what's happening plant community wise, see what changes in the spring, early summer, see if we see that growth, see if it slows down like it did this past year. We'll also be working with the other stakeholders to build exclosures, which sort of like it sounds, it's an enclosure, but it's meant to keep something out. And so in this case, the exclosures are meant to keep out the grass carp and give the plants inside of those exclosures the opportunity to grow and reproduce without being fed on by the, this herbivore basically that's swimming in the lake trying to eat them. And that way, we can see closer the potential impact the carp are having outside the exclosures versus inside, and maybe help give some of those native plants, ideally, an edge to come back. And finally, DEEP is working on their end to, if necessary, potentially remove some of the roadblocks for removal of the grass carp, if that's necessary. So, that's something that we'd like to avoid because we're still trying to strike that balance. But if we're seeing at the beginning of the season that we're still in this stable state, and the lake ecosystem does not seem to be changing, they will have everything, arranged to potentially take that step on their end. And then I quickly, before we get into the Q&A session, I wanted to hit on some frequently asked questions that, I think you're thinking on your mind right now. Okay, yeah, but what about these things? And so let's get into some of those. And the first and maybe most obvious is, why haven't all the grass carp just died if their food is gone, right? They're eating the plants, and if there are no plants, why aren't a bunch of grass carp floating on the top of the lake? And that's a great question. That seems like what would happen, but the answer, there's actually two parts. The first is actually that they are eating the plant material. They're just eating it immediately as it grows. So they're swimming around the lake looking for food. And as they find that, very low growing plant material that's trying to come back, that's the perfect food for them. They're going to eat that right away. And that's why we're, in this stable state of no plants. They're getting eaten by herbivores that are in the lake right now as they try to grow. And then the other, aspect of this is they're very hardy fish. And so when there's no other option, they actually will begin to eat decomposing algae and biological material at the bottom of the lake too. It doesn't sound very appetizing, but it is something that they have no problem consuming. And it also explains why we haven't actually seen as many of them swimming around this year. They're at the bottom of the lake eating some of that decomposing algae, biological material, and looking for the beginning of plant growth. So they are eating, it's just hard to see. And then the next one, wasn't the point of the drawdown and the carp to get rid of the plants? This seems like a good thing. No, it's definitely not. The lake isn't a swimming pool. It's a complex ecosystem. There are food webs, habitats, lots of organisms that rely on the plants for food, for shelter, and losing the plants can have an unfortunate effect on those organisms. For instance, the sport fish in the lake, you're talking about your smallmouth bass, that sort of thing. Their juvenile fish use the plants as habitat to avoid predators. And so, you definitely want to preserve some of that habitat so those fish can grow, big and strong and be fun to fish when they're adults. The plants also might be a nutrient sink in the lake. So basically they may take some of the nutrients in the water and use it to build up their biomass and taking it away from algae. And so we don't necessarily want all of those nutrients all of a sudden to be available now for the algae that naturally wants to grow in the lake. And so that's something we're keeping a very close eye on too. So all that to say, we definitely want some plants in the lake. The next question, could chemicals or pathogens in the water have caused this change? This is a good question, and it's something we got a lot. And it's something we looked into a lot too. First, regarding the chemicals, in a lake the size of Candlewood, the concentration of chemicals that would be required to see a change of this magnitude, basically going from 400 acres of plant material to 0 in every part of the lake, would be extraordinarily high and expensive. So you're talking about a lot of chemicals, a very expensive purchase, and would require a large scale investment and application that, you know, would be very obvious. You're not talking about something that could be secretly done. You're talking about multiple boats on the lake that would have to be actively applying chemicals. And so we can rule that out. That was not happening on the lake this year. And as for pathogens, there are natural pathogens actually that occur in lake ecosystems for plants, including milfoil. Unfortunately, they're not really possible to test for directly. However, it is possible that a pathogen may have been another contributor to that green arrow that was pushing down our biomass at the beginning of the year. So that's something that we definitely considered. The reason that this is somewhat less likely, though, actually, and this is true for the chemicals question too, is that there are plants in the lakes downstream of Candlewood Lake. So lakes that get Candlewood's water, like Little Nona, Zor, Lake Housatonic, they do have plants this year. And so the lake water from Candlewood is not carrying anything with it, whether that be a chemical or a pathogen, that would then have an impact in the other water bodies downstream of the lake, or else we'd be seeing a similar situation in those lakes. Let me see. What about other lakes with grass carp? What about other lakes nearby that don't have grass carp? This is important for us to consider as we try to think about, okay, what are all the factors that potentially contributed to this change? And this isn't the first story of a lake with grass carp that has, you know, lost all of its pet plants. Ball Pond in New Fairfield, Taunton Lake, Lake Wabeeka, and Squance Pond in Connecticut all are water bodies that have been stocked with the grass carp and have lost all of their plants. Candlewood is the first lake of its size to be stocked in this specific climate. There are many lakes in the south that have been stocked, some of which also lost their plants, some of which have not, but they all have different seasonal cycles and plant communities than Candlewood. So you're talking about lakes that don't have that wintertime seasonality that maybe Candlewood does, and the drawdown and all of those aspects as well. I just mentioned the lakes downstream of Candlewood. There have been some reports of local lakes with lower than normal plant material, less dense, less, you know, than in the past compared to in those specific lakes. That might lead us to consider that that winter climate that I pointed to and the ice and snow cover that we had last year might have had an impact on pushing down that biomass if we're seeing, you know, less dense plants in other water bodies in the area. And so, you know, I think that's relevant. And then finally, what if the grass carp aren't sterile? What if they're reproducing? And that's a good question. But thankfully, I do have good news here. Two pieces of good news. The first is that checking for the carp sterilization, it's a federally managed, regulated program, and it's extremely rigorous because if it weren't, basically you would just be purchasing an invasive species, right? You'd be putting a new species into an ecosystem that could potentially have a negative impact, and they would be reproducing. So there'd be no recourse, right? So you need to make sure that they're sterile before they're sold, or else, you know, you'd be knowingly transporting invasive species. So the management and regulation of that is very rigorous. The other good news is that a juvenile grass carp has never been found in the lake, whether that was by the CLA, homeowners, anglers, or by DEEP, who conducts electrofishing inventories in the lake. There have never been grass carp juveniles found in the lake. And so no evidence there of reproduction. Keep in mind, there are common carp in the lake. Those are native species. They're not sterile. They've always, you know, sort of been, you know, friendly big fish in the lake, but they're native and they don't feed on the plants. So we're talking about two distinct species here, the grass carp, which are sterile, and then there are the common carp. And that is the information that we have for you. So, you know, thanks again so much, everyone, for joining us. Please, now's the time for questions. So type them in the chat and Mark will read them and I'll do my best to answer them. And if you don't have any questions, have a great night, and we'll post this presentation, like I said, on YouTube, Facebook, and our website later this week. So thank you again.
Okay. Hey, Neil. Yeah, we have a ton of questions, and I've been furiously trying to write them down. So hopefully I don't repeat anything you've already answered.
Great.
But one of them is that people are asking is the life expectancy of the carp. I didn't know if you touched on that already.
Yep, no, that's a great question and not something that I mentioned. So the carp life expectancy is a little bit based on the climate, but when you're talking about northern climates like in Connecticut, they tend to live 10 to 15 years. There's going to be some natural death of fish, every year, just as the nature of, being alive, but, think 10 to 15 years on average.
Okay. Another common question that came in had to do with algae blooms, and
Yep.
if there is any connection, especially with the late season winter blooms that we've seen, or potentially future blooms. Would we expect future blooms? And then sort of a follow up to the blooms is wondering. This was a question more specific to the winter blooms, but are they of the blue-green, algae / toxic type that could be a danger to pets?
Excellent questions. That is something that, we're concerned about. So as most of you probably know, there have been substantial blue-green algae blooms in the lake this past winter. Part of that may be an effect of more nutrients available due to the lack of plants this past summer, but this winter has been unseasonably mild. And so after the lake, quote unquote, turns over in the fall, that basically makes nutrients that were stuck in the bottom level of the lake all of a sudden available at the surface. And so in the fall, you often see blue-green algae blooms when all of a sudden that nutrient material that's trapped in the bottom of the lake is available at the surface. But that tends to end once the water temperatures get cold enough to push the blue-green algae back a little bit. And so we haven't gotten those cold temperatures yet. So I think there, might be an impact of not having the plants, but I also really point to the weather that we've had this year as the main culprit for the blue-green algae we're seeing right now. That said, like I mentioned, the plants may be a nutrient sink for the lake. And so when there are no plants, it's possible there are higher nutrient availabilities for the algae that's growing in the lake. And so that is something that we definitely want to avoid. Thankfully, this past year, I didn't get into much lake chemistry in this presentation, but our annual report of the lake chemistry will be posted on our website actually this week. And we're looking at this past summer, has been on the greener side of average, but it's not a year that, was different in our metrics. It was within the bounds of, normal years. And I don't have that figure to show you here in this presentation. But we'll do another presentation soon on the lake chemistry from this past year. And we'll keep a close eye on blooms moving forward, because it may be an impact from the loss of plants. And, the best advice I can give for the pets question is, if it looks like you wouldn't want to jump into it, then, don't let your pets jump into it. So if the lake looks green, potentially if it has, spilled paint or pea soup appearance, keep pets, keep children, don't jump in, keep them away, from the lake. That's the best you can take, because there's no way to know for certain if a bloom is potentially going to have those toxins or not without it taking the sample to a lab.
Okay. So there were a few questions that came in about native plants, and wondering about, well, first, one of the questions was just sort of wondering what type of native species we do have in the lake, and how they were affected by this? And then secondly, the questions in general people are asking is there a way, or is it possible or reasonable to introduce native plant material back into the lake, since we do not have the milfoil dominating right now?
Yeah, definitely. No, those are both really good questions. And so there's one, sort of main native plant that has sort of found a niche in the ecosystem and actually has been pretty successful. And that's the common name is coontail. It actually looks kind of like milfoil, but it's a little bushier. Um, and the milfoil tends to dominate the ecosystem, but the coontail have figured out a way to grow a little deeper on the outer edge of some of those milfoil beds. And so coontail is the main native species that we've historically had since we've had milfoil, but there are a number of pond weeds, tape grass, all sorts of other, smaller scale native species that have been found in the lake in the past, 40 years. And so we are presented, potentially with a little bit of an opportunity to help give those native plants another little bit of an edge here against the milfoil, since, the milfoil isn't currently, all over the lake. Now, I will say we are still finding milfoil in the lake. It's definitely still there. And so we're not talking about a situation where all of a sudden milfoil has been eliminated from the ecosystem. And since it's not native, it's not coming back. It's in there and it's going to continue to try to grow. And it will grow successfully. But when we're designing these exclosures and choosing a location for them, the priority is going to be choosing a location that historically has been, a little better for native species. And potentially we could sort of seed those exclosures with native species to, give them an edge, protect them from the fish, and allow them to reproduce inside of those exclosures with a little more success potentially.
Another common question, which I just want to get answered, although I don't think there's necessarily an answer to it, is sort of people asking, what are you expecting for this season, and sort of the future of the plant population?
Definitely, yeah, it's a good question. And so, like you said, I can't give you a for certain answer, right? I'm sort of speculating based on the information that we have, and talking about those stable states. The ecosystem now is going to want to try to stay in the stable state of plants. Now the hope is that it's a little less stable than maybe we think, and some natural death of the fish, milder winter, some small factors might be enough to push that that stable state back over the hill here, like we were talking about, and back into this, more stable state of overabundance. And then we're back to dealing potentially with overabundant plants. I don't necessarily know if that's going to happen this year. That's my hope, but I tend to think the ecosystem is going to want to stay in this, stable state of very little plant material. And so we're going to have to work on potentially pursuing some of those, management activities to try to begin to push this, this way. And as the carp age out, they die out. Those are all factors that are going to start pushing this direction. We're going to work with First Light. They had to do maintenance this year, but next year we're going to advocate for a shallow drawdown. Do all of these things to try to get the plants an edge. And so I definitely don't expect this is forever. The plants will come back. The question is this change going to be for 1 year? Is it going to be for 3 years? Or is it going to be for, 5 years? And that's, where we're at trying to figure out right now.
Okay. So some questions came in just about the effects of the loss of biomass and the rest of the fish population on the lake.
Yeah, I mean, it's a great question. So, like I mentioned, here, the plants do play a really important role in the ecosystem, providing habitat for fish fry in the lake. And so when a fish reproduces, you have a really small fish fry that eventually will grow into these awesome sport fish that we have. And so part of the concern is that without that habitat, the fish fry aren't going to be as successful. And that may be the case. Hopefully the fish are finding alternative habitats in the lake, whether that's stones, whether that's fallen trees and logs on the shorelines, docks, sort of man-made habitat that they can use. And so the fish are going to try to find a substitute habitat, and some of them will be successful and some of them won't be. So you might see an impact on the fish community a few years down the line, but as the plant community recovers, that fish community will also be able to recover as well, if that happens.
Another question that's come up a few times is just about the fact that there are also other carp in the lake other than grass carp, and sort of what's the difference between the two, because people see a lot of other carp feeding or carp feeding, and they're wondering what type of carp they are.
Yeah, no, it's a good question. I should have included in this presentation a little diagram showing the two different ones, but sort of anecdotally, a few different ways that you can sort of decipher the differences is the common carp tends to grow out, so they get sort of bigger and chunkier as they grow larger, and the grass carp actually tend to grow longer. They do get chubby, but they grow pretty long, and so they get big, but they tend to be a little longer than the common carp. The common carp also can have a pinkish orangish color that the grass carp generally don't, that they're more gray, greenish. And if you're able to spot their whiskers or lack of whiskers, if they have whiskers, they're a common carp. The grass carp whiskers are very small. And then finally, the dorsal fin on a grass carp is one sort of tall dorsal fin. It's not like a shark. It doesn't stand up, but it's small. And then on a common carp, it's long. It sort of goes along their entire back. So those are sort of different things that you can look at. Am I feeding potentially a grass carp or a common carp? Those are the things that you can kind of see about looking at.
Okay, and I'm sorry, Neil, I was writing things down, but did you just mention as far as sort of what the common carp, what they're feeding on versus the grass carp?
Oh, no. So the common carp, they tend to feed on the detritus on the bottom of the lake. Also, small organisms that are alive sort of in the shallows of the lake, they'll eat those. But as things decompose at the bottom, they will eat those too. Similar to the grass carp, that's sort of the bottom of the grass carp's choices, but the common carp are sort of more willing to go there at the beginning.
Great. Thanks. All right, and we have just tons of questions coming in. We've got about 5 minutes left, but there are lots of questions, so we'll get to as many as we can. Is it possible this year, Neil, that we might see a lot of plant growth? In other words, it disappeared very quickly. Is it possible that it could return as quickly?
Yes, definitely possible. It may be the case that this just happened to occur this year, and that state of very little plant material isn't as stable as maybe we think. But I tend to think that it is relatively stable in this state that it's in right now. And so we may have to work a little bit to push the ecosystem the other direction, but it is definitely possible. It's not out of the realm of possibility for sure.
Some people are asking sort of about the growth of the carp and how long they continue to grow for, and then also how stocking rates are determined for grass carp.
Yep. So good questions. So based on the research that was done when they were stocked, they tend to reach, their full size about after 5 years of being stocked, and they can grow pretty large, up to 20 pounds and even a little bigger than that. They are herbivores, so they will just eat the plants. They're not good fishing fish. They don't really go for bait or lures or anything like that. They'll just tend to just go for the plants. But 5 years they tend to reach their max size, and they can be pretty big. And then I'm sorry, the second part of that, the stocking rates. And so when they were stocked in Candlewood and when they're stocked in, other lakes in Connecticut, that 15 fish per vegetated acre, that was the metric that was used at the time. So you take the total acreage of plants in the lake, multiply that by 15. That when you're thinking about biomass, like we talked about during the presentation, you are thinking about more than just total acreage. So you're also thinking about that density and the plant height. And so, these are things that, as we continue to research this and get more information about the grass carp as a management tool, these are things that, we'll be able to share with other lakes. Let's make sure to keep these in mind as well. And so that is something that, lake communities around the country are learning, that exact, trying to strike that balance that we talked about, right in here. What is that measurement of carp that can strike that balance? And they change. They're just part of the ecosystem. So that's why that trying to figure out balance is so difficult.
There are a few questions that came in about the drawdown, Neil. So why, if the deep drawdown eliminates more plant life, why was this year's drawdown a deep drawdown?
Yep. No, great question. So, we initially had hoped for a shallow drawdown. That's what we approached the power company for. They managed the drawdown. Unfortunately, they agreed with us that would be, great for the plant community. Unfortunately, they have some required maintenance on the dams for Candlewood that requires that they do a deep drawdown. So, unfortunately, they had to do that maintenance. And so we're looking at a deep drawdown this year. But moving forward, until the plants are back at a healthy level, we'll continue to advocate for that shallower drawdown.
Okay, great. And we just got a couple minutes left, and I'll just say one thing. We have gotten a lot of messages and questions about zebra mussels, and so this isn't the forum for it, but that may be another webinar for another time.
And I just want to I got some information from Deep Fisheries too, just to add to what I said about the grass carp. Sort of how they grow and survive. They will grow sort of linearly as they age, and they'll grow continuously. That growth, they don't necessarily always reach a maximum size. They can continue to get larger as they eat more and more. But it does that length growth that does slow down over time. The grass carp in Connecticut have been documented to be living up to 20 years old. So we're not talking about just 10 to 15. Sometimes they can go even up to 20. So just wanted to add that too.
All right. And we'll do one more. It is 8 o'clock, but we'll do one more. And I apologize.
And we will talk more about the zebra mussel. By the way, you mentioned the zebra mussels. That is something that's very high on our priority list as well. And so we'll have more to say about that. But as the drawdown commences, stay tuned. We're going to be posting an opportunity for people to volunteer and get involved and potentially search the shoreline of the lake that's exposed by the drawdown for zebra mussels, and we'll be doing some of that too. So, stay tuned to our Facebook and website and newsletter, and we'll send out the information for that very soon too.
Okay. And we'll just finish up with one more, and then Neil, I think what we can do is we can try and answer some more of these questions, on our website and things like that, and get answers back to people as well. Because there's more.
If you ever want to call and talk to me, my phone number is on our website. You can also email science@candlewoodlakeauthority.org with your questions. I'm always happy to talk lake science with folks. So definitely don't be a stranger.
I think one of the sort of the last questions people are talking about is there any plans or discussion about carp removal?
Yes, it's a good question, and that has been discussed. And so that's actually a little more in Deep's territory. They're making the arrangements on their end to basically make sure that's possible if it's necessary for next year. And so it's my understanding that that is being done. Those arrangements are being made. And should that be necessary based on those really early metrics that we're measuring out there, that's when they'll potentially start to pursue that.
Great. Okay. Well, Neil, thank you so much for the presentation and for answering all the questions. And as Neil said, feel free to reach out to him directly through the Lake Authority. And we appreciate everybody who joined us tonight. We had a big audience, and for all the questions you sent in. And we hope to see you at our next webinar.
Excellent. Thank you, everyone. I really appreciate the attendance, and thanks so much. Have a good night.